The fight or flight response begins when your senses perceive a threat, which could be a lion, like on the EEA, a fast car speeding towards you, or a test scenario that makes you uncomfortable. Once perceived as a threat by the senses, seeing these things, then the senses send signals to the somatosensory cortex in the brain.
This then transmits these signals down to the amygdala, where emotions linked to fight or flight are processed. If the amygdala does perceive the sensory stimulus as a threat, then it sends a distress signal to the hypothalamus. The hypothalamus is essentially the command centre in the brain. Once alerted by the amygdala to the presence of a threat, the hypothalamus does two things. That is, it activates both the SAM pathway and the HPA axis. SAM stands for the sympathetic adrenomedullary pathway, and it's made up of both the nervous system and the endocrine system. The two work together to produce an almost instantaneous fight or flight response. In response to the stressor, the hypothalamus sends a nerve signal to activate the SNS. That is, the sympathetic nervous system, which is part of the autonomic nervous system. Typically, the autonomic system would be in its parasympathetic state, which means at rest. But once the hypothalamus has activated the SNS, the sympathetic nervous system, neurotransmitter noradrenaline is released and sent down the various nerve cells to organs all across the body as a direct signal. One of the most important signals that is sent by the SNS is to the adrenal gland at the top of the kidneys, specifically to the adrenal medulla, which is the section on the inside of the gland. And this then releases the hormone adrenaline into the bloodstream, which travels around the body and produces a range of different effects. These include increasing the blood supply to the skeletal muscle for physical action, increasing the oxygen for the same reason, which then produces increased oxygen being available to the brain as well for rapid response planning. Of course, at the same time as the sympathetic nervous system was sending that message via the noradrenaline to the adrenal medulla, it was also sending messages directly to other parts of the body. The direct effects of these messages were that the heart rate would increase, non-emergency systems were functioning, such as the digestive system, would shut down, and blood supply to the skin would be lowered. Blood vessels would also be constricted, which would increase the rate of blood flow, raise blood pressure, and get the blood pumping around the body more quickly, along with the increased heart rate. Other effects would be increased respiration and sweating. And all of these things would be together preparing the body to respond with either fight, aggression, or flight, i.e. running away from the stressor. So the question becomes, how do these things here, these bodily physiological responses, help with you fighting or running away? Well, it's because you've got an increased heart rate, you've got increased oxygen, increased blood supply, all of these things provide energy to the body more effectively, which means that you have a burst of energy so you can actually deal with the amount of energy needed to regress or the amount of energy you need to run away. That's why non-emergency systems such as your kidneys, your digestive system, your blood flow to your skin, that kind of thing cuts down, because these don't need to be in operation at that point. That's also why you feel sick to the stomach, why your mouth goes dry, why you might feel cold when you're particularly nervous, anxious or threatened, because these things are happening. Of course, another advantage of the blood flow being lowered to the skin is if you do get into a fight and you do get harmed, then you will lose less blood. So that's another adaptive response there. The sweating makes you much harder to grab if you are running away. If you're slippery and so on, you become a more difficult target to get a hold of. Not just that, but it helps cool the body while you're involved in that exertion. And again, this explains why we sometimes perspire a lot when we are very nervous. Now, all of this with the SAM is actually your acute response to stress. So your instantaneous response to an acute stress is something very threatening indeed. If that threat is perceived to disappear, then at that point, what will happen is the sympathetic nervous system will quieten and the parasympathetic will come back into operation. That is, of course, the other part of the autonomic system. And when the parasympathetic comes back into operation, this starts to shut down the functions of the sympathetic nervous system and puts the body back into a state of rest. So at that point, your heart rate slows, your blood supply quietens down, you have less rapid breathing, your veins deconstrict, your digestive systems, your kidneys, all the non-essential functions come back online, stop perspiring, and your pupils, which had been dilated, sorry we forgot to mention that earlier, now constrict because they don't need to let in quite that amount of light for the really clear sight needed to respond to a potential threat. So all of these things just quieten down and you go back to being at rest. And this is because the adrenal gland stops producing adrenaline. Now, SAM, the sympathetic adrenal medullary pathway, really is what we're talking about when we talk about the fight or flight response coming into operation. It's the combination of the sympathetic and parasympathetic nervous systems working together that make up the fight or flight response and the quietening of it. However, we did acknowledge that the hypothalamus does two things. It activates two responses. One is the SAM and one is the HPA axis. So HPA axis stands for hypothalamic pituitary adrenal axis, and this is triggered at the same time as the acute stress response, but actually is more ready for chronic stress. Now, what that means is a long-term stressor, and that might not mean exactly what you think it is. So if we go back to our lion, we know this is perceived by the amygdala as a threat, and that sends a distress signal to the hypothalamus that triggers the two things, SAM and the HPA axis. Now, like I say, SAM is really the fight or flight response because that is the response, the acute response to the stressor, which means that it acts instantly, pretty much. The HPA axis is actually much more based on the endocrine system. It's not accessing the nervous system in the same way, and therefore the messages sent are a little slower. So when we say a chronic stressor, we actually mean one that goes on for about more than 20 minutes, because the fight or flight response is actually incredibly draining on the body, and therefore the body can't maintain it for that long. So by the time that the fight or flight response starts to dissipate, the 20 minutes will have passed, and if you are still being chased by that lion, then that's when the HPA axis will start to kick in and that will take over. Now ideally, that chronic stressor, 20 minutes plus, won't last particularly long. If it does, then as we know, you can get stress-related illnesses that are linked to the constant production of the hormones related to the HPA axis. But in the short term, it's actually very, very useful. So, how does this endocrine-based response to chronic stress actually help us respond to the stressor? The first thing that happens is the hypothalamus, which is here, alerts the pituitary gland, which is here, to release a hormone known as ACTH, which is adrenocorticotropic hormone, into the bloodstream, where it travels to the adrenal cortex of the adrenal gland, the adrenal cortex being the outside layer of the gland. This is then stimulated to release glucocorticoids, particularly cortisol. The glucocorticoids such as cortisol then travel to various organs and cause lowered responsiveness to pain, quick bursts of energies, and increased blood pressure. So after about 20 minutes, the body is ready to sustain a burst of energy, even though the fight or flight response is now diminished. And so if that pesky lion's still chasing you, you still got greater energy and some adaptive characteristics to help you get away safely. And do be aware, whilst you might talk about both the HPA axis and the SAM system within a question, it's really SAM that they're looking for if they're asking about the fight or flight response. They really want to know about the sympathetic and the parasympathetic system.